Hello, welcome to, a video of some LeetCode problems done in Rust. To start off, I'll just be doing, some easy problems. This is just for my practice, and perhaps some tad bits will be useful for you. So I guess first we'll start off with two-sum, then we'll go to palindrome numbers, and then finally end with Roman 2 integer. So let's start with two-sum. So the problem here is just finding indices that add up to a given target, and you're given a nums array. So for example, our target is 9, and if we're passing this array, we want to return 0 and 1 because these two add up to 9. So we would return 0 and 1. Similarly, in here, we want 6, and we're given 3, 2, 4. We want to return 1 and 2 because that is what adds up to 6. And for example, here, we return 0 and 1 because 3 and 3 add up to 6. So I like to try to practice and use more data structures just so it helps me just use them for whatever, but data structures are pretty cool. I guess I'll let a few minutes or a few seconds go by before I provide my solution or my approach. So feel free to pause here for a bit and write down your own ideas on how you'd approach this, and then kind of come back. Okay, so we'll start to go over my solution using a hash map in Rust. So I guess my initial idea is that for the base case here, let's say that no indices add up to our target, we just return an empty vector. Now, the reason why I want to use a hash map is that we only have to look over a number once. So I guess my idea is that for any entries in this vector, we just iterate over each one, and then pretty much we just add some key and value to the hash map. And then we also do a lookup on the complement of this number to see if it exists. So, for example, we always add the first number to the hash map because there's obviously no complement. So, for example, we add 2 to the hash map, and then when here we're on 7, we want to look up to see if the complement 9 minus 7, 2 exists in the hash map, and yeah, it does. So then with this, we would return a vector which has doesn't have to be in any order, but pretty much the indice which 2 and the complement exist, and 0 and 1. Perfect. Similarly, we go in this example, we add 3 to the hash map, and then we come here. Do we see 4 in the thing? No, and then we just like add it to the hash map, and then go next here. So 4, we do 6 minus 4, which is 2. Do we see 2 in the hash map? And the answer is yes, we do. So then that's why we return 1 and 2, and similarly so on. We go there. So here we will import the hash map. Oops. And we will declare a hash map here. Now for each index and value in the vector, we will get the complement, which is the target minus the current number we're looking at. And if the map contains the key, then we just simply return that we have found. We simply return the index at which this the complement exists, and then the index of the current number that we have iterated on. Now and by default, we always just insert the key, which is the number and its index. And at the end here, we just, we just return an empty vector at the end. Oh, I forgot a semicolon. And here we go. We pass all 3 test cases. We can submit. And there we go. Now we can go talk about palindromes. This is the next problem here. So problem is pretty much just given an integer, return true if it is a palindrome, and false otherwise. Palindrome is basically when it's the same forward and backwards. Yeah, and here are some test cases which we can talk about. So yeah, as you can see here, negative numbers cannot be the same, and it must read the same left to right and right to left. For this one, I don't think you need to use a data structure at all. It's just a simple reading left to right and right to left. So I will pause here for a bit. Feel free to pause and think of a solution, and then you can come back and discuss. Okay, so I'll discuss, I guess, my approach. Keep in mind that my approach probably is not the most efficient. It's just the one that came up to the top of my head, and I had to cover a lot of edge cases that may or may not, or it could be done more optimally in a different way. I guess starting with the base case here, like if x is less than 0, any negative numbers, this should always be false because like in this example, the reverse of this is 1 to 1 minus, and that's not really a number. Another issue I think I came across was the remainder. When you take the last thing and it's 0, like in this case down here, this should be false. But pretty much the general idea was that let's say you keep track of your starting number x, and then your reverse number, which um, starts out at 0. And then pretty much each time in a loop, you want to take like the last digit of x and then um, pretty much add it there, or to the last digit there. So the kind of the math behind that is like pretty much you want to multiply this by 10, uh, your reverse number, which would uh, add like an extra digit there, and then you just want to add the current number and its modulo 10, which is the remainder, or pretty much gives you the last digit. And then you finally want to remove that last digit from your original number. And you keep running this while your original number is greater than your reverse, because then at some point you will get, they should be like equal digits, or that it'll be one digit off, but it is the same as the original. So eventually you're just like taking out digits like 1 and adding it here, and then 2 adding it there until, or like they're equal. And yeah, that was kind of the idea I had in mind. So going back here to cover first the edge case, I did if it's less than 0, or the remainder of that is 0, and the value itself is not 0, return false. And then now here we keep track of our variables that we use. So we have x as our original and our reverse. And pretty much while x is greater than our reverse, we want to add a digit and then add the remainder, and then remove the last digit of the original number. And pretty much here at the end is we return whether or not that the digits are, they're the reverse, and then the original are, or the truncated one are the same, or that they're, just off by one digit. And we pass all of these test cases here, and we can submit. Cool. Now you can move on to Roman to integer. Pretty much it's just translating a string into an integer value. And here we have a table of what things map to. And we have some test cases here where this should be 3, and an explanation of test cases here. So now I guess we can pause for a bit, can come up with an idea of what to do, and then come back, and then I'll discuss my approach. Okay, so let's go to my approach. I think this could be done without using a hash map, which would save memory, but I guess for the sake of me practicing data structures, yeah, I decided to go with a hash map. So pretty much inside the hash map, I would store this just so I can have a value reference to look up. So just the map would contain like is like 1, etc. But pretty much the idea was that I would look up every um, I look up every character in a string. Yeah, for each character, what I would look up is the value, and I would also have a result variable which starts at a 0. So I would always add the value of C, and then here is where I would do a little additional checking. So for example, if the current index in the string, like we're looking at the character, if pretty much I want to see if the next one is, we're not at the end of the string yet. And then if, let's say like we compare uh, the current like position and then the next position, right? I want to see like if this letter here is less than this letter there, and if so, we can subtract the value of this one while we just keep adding this one. Because if you see the trick here, that these letters are only placed before um, the bigger ones. And for example, like I can go before V, but and then I can go before X. Um, and pretty much in these cases, this is what I use to simplify, I guess, the problem for me. So for example, like here, this one is less than this one, so we can just subtract the value of this but add this one, which would be 900. So this is like 1,900. I think this is 90, and that's 4. So then that's kind of the idea I had. And then we would yeah, just continue on the loop here, loop back to the top, and then just repeat this, and then until we get to the end of the string. So let us write this up. So now let us create the map and insert all the default symbols. Okay, now here we will keep track of the result, and pretty much for each character in the string, let's extract the character first, and then now let us see if we want, and then we want to compare this against the next character in the string. So let the next character be that, and then if the value of the this current character is less than the next character, we want to subtract the current character. So for example, that's like the I before the V. Then we want to just continue the loop because then we don't want to double add the value because you want to subtract instead of, or we don't want to negate it, we want to subtract. And then this is where we pretty much, if the character is not less than that, we want to make sure we add it to the result, and then we just return the result here at the end. And we can see we passed all the test cases. I can submit this. And we pass, but you can see it doesn't beat a lot of the test cases and not a lot of memory because obviously I'm using a hash map, but I would like to get more familiar with using structs and stuff, or data structures like that in Rust. And yeah, and if you would like to see the code for pretty much all these LeetCode problems, you can go to my GitHub here, and I will also leave a link. Yeah, thank you.